prepare for written with this.
Okay, so these are got a story, but only if you shut your pie holes. Yes, there we go. All right, there you go. Okay, so this is a solid fuel engine. Solid fuel engines, obviously, when we built a rocket to go to the moon, we didn't use solid fuel engines, right? Liquid fuel engines can generate a lot of thrust, okay? But the space shuttle, when it was operational, used those boosters on the side were solid fuel engines. This it has going for it though. Solid fuel engines are deadly simple. You've got some sort of nozzle here that's heat resistant material. You've got some kind of fuel inside there, okay? And the fuel just has to burn. It has to not go boom, it just has to burn at a steady rate, and it will generate a lot of thrust. You can carry a solid fuel rocket engine in your backpack. It's relatively safe as like a firecracker. And when you need to kill a tank, you can pull it out, hook it up, and it'll just go and do its stuff. Okay? Liquid fuel engines use cryogenic liquids like liquid hydrogen, liquid oxygens. Not so easy to use in the middle of a desert. Okay? Now, when you buy these things, we already talked about how if you've got a big delta V, you get a lot of force, but it also means a lot of pressure. So whenever you're designing a rocket like this, you're always trying to design them so that they're just about to explode, but they don't explode. Right? That's the best, right? Okay. Now, this, if you look at this, notice that it gives the maximum total. I'm not making this up. This is the data sheet that comes with it. Impulse in newton seconds, average thrust in time, in pounds and newtons. It's got this should say mass in grams, right? And then it's got all the force thrust curves, right? Okay. Now, the first thing I did as a physics teacher, I thought this would be a clever idea. I thought this was a good idea. I didn't do the calculation. I just knew it was a good idea. Okay. I said, hey, I'm going to show these kids a rocket engine. So do I buy a small engine?
No.
No, you really want to show them a rocket engine. So I bought, what did I buy? What do you suppose? Yeah, baby, I bought a D12. It's the biggest engine you can buy without a license. They make other numbers. They make like, I don't know, E, F, G or something like that, but you have to have a license. It means you like know what you're doing, right? Okay, now, I buy this thing, and the first thing I do is I strap it to it. We had these little aluminum dynamics carts. They had these super duper ball bearings, and they were super lightweight, right? And so, basically, 20 newton seconds is equal to force times time, right? Okay. Now, what I did was this is our force times time, right? Is 20 newtons times seconds, right? So it could be 10 newtons for 2 seconds, right? Or it could be 20 newtons for 1 second. I don't really care. What I did was I strapped it to a dynamics cart that probably weighed about a pound, super lightweight. Okay, that's about a half a kilogram. Well, I think you can calculate what the delta V is going to be. What do you suppose it's going to be? 40. Is that fast? Is 40 meters per second fast?
That's pretty fast.
That's freaking 90 miles an hour, right? So, did I do that calculation first?
No.
No, I just strapped that baby onto the cart and I said, watch this. Right? So we went out in the hall, and I had all the kids, for some reason I was like somewhat safety conscious, right? So I had them all stand, there was like a raised edge with a radiator on it. They all stood up on that. We put the cart on the floor, right? And I lit it off, and you never, don't light these off inside, especially like a big engine, like a D engine. It filled the hall with this acrid sulfurous smoke. So we really don't know what happened. Okay? It just kind of filled the hall with flame and smoke. And we heard this massive collision at the end of the hall. The hallway went like this, right? And then it was this way, and then this was like how you got into the girls' locker room was right there, right? The thing went, and as far as we can tell, it traveled about 10 feet on the ground. After that point, it left the ground and started flying through the air about waist level, because it's a lot of thrust. From here to here, it was airborne. It struck the wall at about chest level, right? And the kids said that I knocked a hole through the wall, which is not entirely true. It did not go through the wall, but it did. It was a cinder block wall, and cinder blocks are not all that strong. If you hit one, they've got air cavities in them. Do we know this?
Yeah.
Right. You hit one right smack on an air cavity and poked a hole in the wall, literally as a concrete wall. It sort of smacked it. And some guy who probably got paid more than me had to go in there and chip that cinder block out of the wall and stick another one in, and then do all that stuff, right? But yeah. Here we go. I'm always learning physics.
That's the physics teacher right there.